Your F-150 rolled off the assembly line with a handful of factory settings and hidden traps designed to satisfy federal regulators, but they are quietly starving your turbochargers of oil until they completely self-destruct. I have spent over 15 years in the bays tearing down these EcoBoost engines, and I see the exact same preventable failures week after week. We are talking about scored bearings, severe shaft play, and that unmistakable, high-pitched whistle right before the whole unit lets go. The owners did nothing obviously wrong. They simply drove their trucks exactly how Ford set them up from the factory. Today, I am exposing the hidden mechanisms choking the oil supply to your most expensive engine components and showing you how to fix every single one of them. Let us start with the silent killer that almost no owner connects to premature turbo wear, your automatic start-stop system. On nearly every modern 2.7 and 3.5 EcoBoost F-150, the engine kills itself the exact second your wheels stop moving at a red light, then fires right back up when you lift your foot off the brake. Ford did not engineer this feature to prolong the life of your powertrain. They threw it in strictly to hit corporate average fuel economy targets. Here is what they leave out of the owner's manual. Your turbocharger spins at speeds exceeding 100,000 revolutions per minute, relying entirely on a microscopic, pressurized film of oil flowing through its center journal bearing. The very instant that engine shuts down, your oil pressure drops straight to absolute zero. The internal turbine shaft is still spinning at incredible speeds, completely glowing from exhaust heat, but its lifeblood has vanished. Picture this. You just spent 20 minutes pulling a grade or fighting highway traffic. Your turbos are completely heat-soaked, and you hit 3 consecutive red lights on your off-ramp. That is 3 immediate hard shutdowns where the bearing is forced to coast to a stop with zero fresh oil pressure reaching it. Over tens of thousands of driving cycles, this microscopic friction creates devastating bearing wear and creates the exact shaft play that causes your turbo to start smoking and throwing codes. The actual fuel savings from this system are practically invisible, maybe a fraction of a mile per gallon, saving you a measly $50 a year. Meanwhile, a proper turbo replacement on these trucks easily commands $1,500 to over $3,000 once you account for the brittle manifold studs that inevitably snap during teardown. The fix for this costs you absolutely nothing. There is a physical button directly on your dash or center console featuring an A inside a circular arrow. Train yourself to press it every single time you start the truck. If you hate pressing it manually, a $100 aftermarket bypass module will plug right in and remember your preference permanently. The next massive vulnerability is not a factory setting at all. It is a widespread driving habit that represents the single most overlooked cause of turbo oil starvation on direct injected platforms. When you work this truck hard, towing a travel trailer, hauling a heavy payload, or just running 80 miles per hour down the interstate, and then pull straight into a parking spot and immediately cut the ignition, you are committing mechanical malpractice. By shutting the key off instantly, you trap a stagnant slug of scorching engine oil inside the turbocharger's center housing. The exhaust side of the housing is still radiating immense heat from the combustion process, and that extreme thermal energy transfers directly into the stationary oil. This process is called thermal coking, which is just a mechanics term for baking engine oil into solid carbon crust. These hard carbon deposits steadily build up inside the microscopic oil feed passages and around the delicate bearing journals. This creates a dual-threat failure mechanism. The crust physically restricts the volume of fresh oil that can pass through during your next drive, and the loose carbon particles act like industrial sandpaper directly on the spinning shaft. Granted, EcoBoost turbos utilize a water-jacketed cooling system that activates a natural thermosiphon effect after shutdown to circulate coolant passively. However, passive coolant flow does absolutely nothing to dissolve carbon that is already baked solid, and it cannot restore an oil passage that is already halfway choked closed. The solution is free and requires less than 2 minutes of your time. Whenever you exit the highway or unhook a trailer, let the truck idle for 60 to 90 seconds before turning it off. This brief idle period keeps the oil pump spinning, continuously moving fresh oil through the hot bearing to safely carry the residual heat away. If you have just spent the last 5 minutes creeping through quiet residential streets at low speed, your turbos have already cooled down sufficiently. But after a hard pull, that 90-second cooldown is the cheapest insurance policy you can buy. While we are discussing the mechanics of oil coking, your choice of oil viscosity and quality plays a massive role in this equation. And a staggering number of truck owners are getting this wrong. Ford specifies a highly specific lubricant for these engines, typically a low viscosity, full synthetic or synthetic blend. This oil has to navigate incredibly tight tolerances while operating in an environment that is brutally hot. Cheap, conventional base oils and generic bulk shop fluids oxidize and break down at much lower temperatures, forming varnish and carbon deposits far faster than a premium, high-quality full synthetic. If you are rolling into cheap, quick lube joints and letting them dump whatever mystery fluid is, sitting in their bulk basement tank to save $10, you are actively introducing a fluid that will fail inside your turbocharger center section. Stick exclusively to a high-quality full synthetic that explicitly meets the current Ford material standards. This isn't about snobbery or buying a flashy label. It is about the fact that your turbocharger bearing is the most punishing environment inside your entire engine. And oil stability is the only thing standing between a clean oil line and a clogged one. This brings us directly to the factory maintenance intervals. Because even the highest grade synthetic fluid cannot protect your bearings once it has been pushed past its mechanical limit. The oil life monitor on your digital dashboard will cheerfully instruct you to run upwards of 10,000 miles before performing a service. And Ford's marketing materials support this under what they call normal driving conditions. Here is the reality from the shop floor. Virtually nobody uses an F-150 under normal conditions. If you tow, carry tools, idle at job sites, navigate stop-and-go city traffic, or operate in freezing winters, your truck falls squarely into the severe duty category. As oil ages inside a turbocharged engine, it suffers from fuel dilution due to the direct injection system, shears down mechanically, and loses its vital additive packages. Once that happens, its ability to resist extreme heat completely evaporates. Old, thinned-out oil cokes almost instantly upon contact with a hot turbine housing. For an EcoBoost that actually works for a living, 5,000 miles is the absolute maximum limit you should ever run between oil changes. Your dashboard monitor calculates its percentages based on generic algorithms, but it has no idea how much carbon is currently baking around a turbocharger that runs hotter than the rest of the engine combined. Beyond the fluid itself, there is a physical component hidden inside the engine plumbing that almost no owner realizes is there, and it is actively dictating whether your turbo lives or dies. Certain generations of the EcoBoost platform utilize a tiny, microscopic mesh oil filter screen tucked directly inside the turbocharger oil feed lines. This ultrafine screen was designed to catch minor engine debris before it could scar the turbo bearings. The fatal flaw is that if a previous owner stretched their oil changes or used inferior oil, this tiny screen plugs up with carbon deposits. A clogged feed screen does exactly what you think it does. It completely chokes off the volume of oil traveling to the turbocharger, even while your main dashboard oil gauge reads perfectly normal engine pressure. Owners get completely blindsided by this because the truck runs beautifully right up until the moment the turbo bearing starves, seizes, and snaps the turbine shaft clean in half. If your high-mileage truck has these screens, they must be inspected or replaced if service is performed near the plumbing. A $10 mesh screen left ignored can easily cascade into a multi-thousand-dollar engine repair. You see, managing these trucks is a constant battle against hidden programming that favors short-term laboratory test scores over real-world, long-term durability. We have only scratched the surface of how factory configurations work against the mechanical longevity of your truck. And there are still several critical settings and overlooked habits that are actively shortening the lifespan of your powertrain right now. We just uncovered how factory start-stop settings and lazy shutdown habits create a silent drought inside your F-150's turbochargers, baking your oil into an abrasive carbon crust. But as devastating as that gradual starvation is, it pales in comparison to a second, deeply buried factory configuration that is actively torturing your entire powertrain under the guise of saving you money. This is the setting that causes the most rapid, catastrophic mechanical carnage I witness in my shop. It doesn't just slowly wear down the bearing over 50,000 miles. It aggressively forces the turbocharger to operate at peak thermal limits under maximum workload, multiplying the destructive forces inside the engine housing exponentially. I am talking about the factory eco mode setting, and specifically the widespread, disastrous habit of leaving your truck locked in this mode while you are towing or hauling heavy loads. To understand why this is an absolute death sentence for an EcoBoost engine, you have to look past the dashboard and understand exactly how electronic modules manipulate mechanical hardware. When you twist that drive mode dial to Eco, the powertrain control module fundamentally alters three critical parameters: throttle mapping, transmission shift scheduling, and wastegate modulation. To squeeze out every possible drop of fuel efficiency, the computer dulls your pedal response so the engine doesn't rev freely. Next, it forces the 10-speed automatic transmission to upshift as rapidly as humanly possible, keeping the engine speed trapped in an incredibly low RPM band, often hovering right around 1200 to 1500 revolutions per minute. Now, imagine you hook an 8,000-pound travel trailer to the hitch, pull onto the highway, and leave the truck in eco mode. You approach a long, sustained highway grade. In a naturally aspirated V8 engine, the transmission would immediately drop 2 or 3 gears, sending the engines spinning up to 30,500 RPM, where it can naturally use horsepower to pull the hill. But your EcoBoost is trapped in a software-induced straitjacket. The programming desperately tries to maintain 10th or 9th gear to prevent the engine RPM from rising. Because the engine is spinning so slowly, it cannot move enough air naturally to pull the weight. To compensate for this artificial lack of horsepower and fulfill your demand for speed, the computer commands the turbocharger wastegates to slam completely shut. It forces the turbos to step in and do the heavy lifting. Suddenly, those small turbochargers are commanded to cram maximum boost pressure, sometimes upward of 15 to 20 pounds per square inch, directly into an engine that is fundamentally lugging in too high a gear. Mechanics call this high load, low RPM operation, and it is the absolute worst psychological profile you can subject a turbocharged engine to, when a turbo is forced to generate maximum boost while the engine is turning slowly. The volume of exhaust gas exiting the cylinders is moving at a relatively low velocity compared to the sheer pressure being demanded. This creates an immense aerodynamic bottleneck right at the exhaust turbine wheel. The exhaust gas backs up, creating extreme back pressure and turning the turbocharger's turbine housing into a literal blast furnace. The temperatures inside that small iron casting rocket passed 2600 degrees Fahrenheit in a matter of moments. This extreme thermal energy creates a massive temperature spike that completely overwhelms the engine's cooling capacity. While the main engine temperature gauge on your dash stays neatly centered because the radiator is massive and doing its job, the localized heat inside that specific turbocharger housing is liquefying the protective properties of your engine oil. The microscopic oil film separating the spinning shaft from the brass bearing faces completely shears down under the combined assault of extreme heat and immense thrust loads. The shaft begins to deflect, making microscopic physical contact with the bearing walls. Let me give you a concrete example from a truck that towed into my center bay just last month. The owner was a meticulous guy, a retired engineer who changed his oil every 5,000 miles on the dot using top-tier full synthetic. He brought me his 2021 3.5 EcoBoost with only 42,000 miles on the odometer. The truck was making a horrific metallic scraping noise under load, and the dashboard was lit up with a P0299 underboost code when I pulled the intake plumbing off the passenger side turbo and grabbed the compressor nut. My fingers could physically rock the shaft back and forth by almost 1/4 of an inch. It was completely shot. The compressor wheel had shifted so far out of alignment that the aluminum blades were physically carving into the outer housing. throwing microscopic metal shavings straight toward the engine cylinders. I pulled the service records and sat down with the owner. He proudly told me that he kept the truck locked in eco mode for the entire 300-mile trip across the state because he wanted to optimize his fuel economy while towing his boat. He thought he was being smart, protecting the engine by keeping the RPMs low and quiet. What he didn't realize was that his software settings had forced his turbos to run red hot at full boost for 4 hours straight, while the engine lugged along in 10th gear. The oil passages feeding that specific bearing were completely cooked solid, choked with black, crusty carbon deposits that looked like burnt coffee grounds. The oil supply was totally choked off, and the bearing literally melted itself to the shaft. A driver who thought he was treating his truck with absolute care walked out of my shop with a $3,500 repair bill, all because he trusted a factory setting to manage his workload. Ford actually explicitly buries a warning deep inside the towing section of the digital owner's manual, stating that you should never tow or haul heavy loads in eco mode, advising drivers to use tow haul instead. But they don't explain the catastrophic mechanical why, and they don't make tow haul the default. They leave it up to you to change it every time you hook up a trailer. The immediate, zero-cost fix to preserve your powertrain is to aggressively match your drive mode to the actual physical work the truck is performing. The very second you drop a trailer on the ball or load down the bed with material, click that mode dial directly into tow haul. Tow haul mode completely rewrites the computer's operational logic in favor of mechanical durability over laboratory emissions testing. It recalibrates the transmission to hold on to lower gears much longer, preventing the engine from ever lugging under load. By keeping the engine spinning at a healthier 2,500 to 3,000 RPM while climbing hills, the engine generates its power through natural mechanical leverage and air volume, rather than forcing the turbos to artificially simulate displacement through pure, unadulterated boost pressure. Furthermore, the increased engine speed drives the mechanical water pump and oil pump much faster, drastically increasing the physical volume of coolant and oil rushing through the turbocharger housings. This extra fluid velocity sweeps the intense thermal energy away from the bearings before it has the opportunity to break down the oil film or cook the fluid into carbon crust. Your transmission fluid temperatures stay lower, your cylinder head temperatures drop significantly, and the oil film inside that spinning turbo bearing experiences a fraction of the thermal stress. You must break the habit of assuming that lower engine RPM always translates to less wear and tear. On a modern, direct-injected EcoBoost engine, lugging the powertrain under heavy load in a fuel-saver mode is the fastest way to turn your expensive factory turbochargers into scrap metal. We are fighting a constant battle against factory calibrations that prioritize EPA certificates over the ACT, UL physical hardware parked in your driveway. And as brutal as eco mode is to your induction system when towing, there are still deeper, even more deceptive factory parameters and habits hidden within these trucks that are quietly working to undermine your engine's longevity. We have already exposed how the factory auto start-stop programming inflicts microscopic flat spots on your turbocharger bearings during everyday driving, and how lugging your truck in eco mode while towing subjects those same bearings to a thermal blast furnace. But as brutal as those mechanisms are, there is one final, incredibly deceptive factory configuration that ties this entire destructive sequence together. This is the ultimate trap because it actively tricks you into believing your engine is operating in perfect health while the turbochargers are gasping for their very lives. I am talking about the factory instrument cluster oil pressure display and its completely artificial normal reading. To understand why this is a massive danger to your powertrain, you have to look behind the plastic dashboard lens and understand exactly how modern automotive electronics function. If you look at the dashboard of your F-150, you see a traditional needle sweeping across a dial marked with an oil can icon, or a digital bar graph that appears to fluctuate based on engine conditions. Most truck owners naturally assume this gauge functions like a real thermometer or a physical pressure gauge, That it continuously measures the exact pounds per square inch of fluid pressure circulating through the oil galleries. That assumption is completely wrong. What you are actually looking at is a software-driven illusion. It is a simulated display controlled entirely by the body control module and a basic binary pressure switch threaded into the engine block. This factory switch is designed to trigger at an incredibly low threshold, usually around 5 to 7 pounds per square inch. The moment your oil pump generates anything above that bare minimum threshold, the engine computer sends a digital command to the instrument cluster, parking the dashboard needle dead center in the normal zone. Whether your engine is producing 12 pounds of pressure or 60 pounds of pressure, that needle stays completely static, locked in place to give you a false sense of security. It is nothing more than a glorified idiot light dressed up to look like a precision instrument. Here's why this electronic trickery is absolutely fatal to your EcoBoost turbochargers. The oil pressure switch reads its data from the main engine oil gallery down near the crankshaft bearings, where fluid volume is vast and pressure is highest. But your turbochargers live at the absolute end of the line, perched high on the exhaust manifolds. The pressurized oil has to travel upward through a series of long, highly restrictive metal lines and pass through those tiny mesh pre-filter screens we discussed earlier, before it can finally lubricate the spinning turbine shaft. As those internal feed lines and mesh screens slowly clog up with cooked carbon deposit, thanks to old oil and high heat, the actual physical volume of oil reaching the turbocharger bearing falls off a massive cliff. The turbo might be receiving only 2 or 3 pounds of oil pressure while spinning at top speed, which is nowhere near enough fluid to maintain the hydrodynamic film required to keep the shaft floating. Yet, because the main engine gallery down below is still maintaining 20 pounds of pressure, the dashboard switch stays closed, and your instrument cluster continues to read perfectly normal. There is absolutely no sensor, no warning light, and no digital readout monitoring the actual volume of oil passing through the turbocharger housing itself. The factory cluster will happily look you in the eye and tell you everything is flawless right up until the exact microsecond the turbo bearing completely seizes, snaps the shaft, and sends catastrophic metal shrapnel directly into your induction system. Relying on your factory gauges to monitor the health of your turbos is like trusting a smoke detector that has been completely taped over. By the time a symptom finally manifests on your dashboard, whether it is a piezo 299 underboost code, blue smoke pouring out of your tailpipe, or the truck slamming itself into limp mode, the damage is already done, and you are staring down a massive teardown. Now that we have stripped away the factory illusions, we can synthesize these individual mechanics into a single, cohesive prevention strategy that protects your investment. Saving these EcoBoost turbos is not about buying expensive aftermarket performance parts or chasing boutique additives. It is about aggressively overriding factory programming with disciplined maintenance and smart driving habits. Your defensive strategy must address the entire oil life cycle inside the engine. Step 1 is eliminating the daily friction cycles by shutting off the auto start-stop system the moment you start the vehicle. Step 2 is halting the coking process by implementing a mandatory 60 to 90 second idle cooldown period whenever you pull off the highway or unhook a trailer, allowing the mechanical oil pump to sweep away the intense heat safely. Step 3 is discarding the factory-recommended 10,000-mile oil life monitor percentage completely. You must transition your truck to a strict mileage-based maintenance schedule, dumping the oil every 5,000 miles at the absolute maximum, and cutting that down to 3,500 miles if you are consistently working the truck in severe duty environments like heavy towing or extreme summer heat. Use only high-quality full synthetic fluids that explicitly meet Ford's structural material specifications to ensure maximum resistance to thermal oxidation. When it comes to putting the truck to work, you must actively protect the hardware by matching your drive mode to the physical load. Permanently banish eco mode whenever there is a trailer hitched to the bumper or weight in the bed, and switch directly to TOW haul mode to keep the engine spinning in its natural efficiency zone. Driving the oil and water pumps at the speed required to keep those high-altitude bearings cool. Finally, if you are driving a high-mileage truck or a used vehicle with a mystery maintenance history, do not wait for a failure to occur. Have a certified technician physically pull and replace the turbocharger oil feed lines and those hidden mesh pre-filter screens to ensure the oil supply route is completely clear. Your F-150 is powered by an incredibly robust, highly engineered piece of machinery that is fully capable of crossing 150,000 or even 200,000 miles without a single complaint. But it can only achieve that longevity if it is given the basic physical resources it needs to survive. Stop letting factory settings optimized for federal test labs dictate the lifespan of the mechanical components you paid hard-earned money for. Override the programming, manage the heat, protect the oil quality, and take control of your truck's durability. If this insider breakdown gave you the exact clarity you need to save your truck from an expensive failure, make sure to hit that like button and subscribe to the channel right now. Drop a comment below and let me know how many miles are on your EcoBoost and which of these factory settings you are going to change today. Keep your tools clean, protect your oil pressure, and I will see you in the bay.